Hello, everyone. I'm Lee Hong Mei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In the previous lesson, we have studied the technologies of data exchange. In this lesson, we will study the error detection and correction in data transmission. The topics we will explore in this mini lecture include parity check and cyclic redundancy check. These two methods are crucial for ensuring the accuracy of data transmission. The teaching objectives of this mini lecture are: 1. To understand the various causes of errors in data transmission. 2. To master the methods of parity check. 3. To master the methods of cyclic redundancy check. First, digital communication systems use binary coding to represent information, where any bit error can lead to serious consequences. Therefore, besides requiring a low bit error rate, the system should also have the capability of automatic error correction. Noise and interference signals are inevitable on communication lines, leading to discrepancies between the received signal and the original data signal, thereby causing errors. Error control techniques are methods used to detect and correct these errors. Next, we need to understand the causes of errors in data transmission. The causes can be divided into internal and external factors. Internal factors include noise pulses, impulse noise, attenuation, and delay distortion. External factors include electromagnetic interference, solar noise, and industrial noise. Now, let's learn the first part, the parity check. To ensure error-free data transmission, we must have error detection and correction functions. One commonly used method is the parity check, a technique to verify the correctness of code transmission. It checks whether the number of 1 in a set of binary codes is odd or even. If it is odd, it is called odd parity. If even, it is called even parity. When using parity check, if two bits in the data simultaneously flip, an error might go undetected. Next, let's understand the methods of odd parity and even parity in detail. Look at the image, which shows the process of using parity bits in data transmission to ensure the accuracy and integrity of data during sending and receiving. First, the sender's computer generates a parity bit according to a specific algorithm and appends it to the original data before sending it out. At the receiving end, the computer receives the data and parity bit and uses the same algorithm to verify the data to check for any transmission errors. If the parity bit check passes, the data is considered correctly received. If it fails, the data may need to be retransmitted or error recovery measures taken. This process is crucial for maintaining data transmission reliability, especially in the presence of transmission errors and interference. Parity check is a method to verify the correctness of code transmission. It checks whether the number of 1 in the transmitted binary code is odd or even. If the number of 1 is odd, it is called odd parity. If even, it is called even parity. Odd parity requires the number of 1 in the original data sequence to be odd. For example, for the data sequence 1000110, we need to add a 0 to keep the number of 1 odd. Even parity requires the number of 1 to be even. For the sequence 1000110, we need to add a 1 to make the total number of 1 even. Next, let's study the second part, the cyclic redundancy check. Cyclic redundancy check is also known as a polynomial code. It generates a redundancy code at the sending end and appends it to the information bits before sending them to the receiving end. After receiving the information, the receiving end will check it according to the same algorithm used by the sending end to generate the cyclic redundancy code. If an error is found, the receiving end notifies the sender to retransmit the data. Cyclic redundancy check can strictly check both random errors and burst errors. The error detection capability of cyclic redundancy check has the following characteristics. It can detect all odd-numbered errors, all double-bit errors, all consecutive errors less than or equal to the length of the check bits, and with a high probability, It can detect consecutive errors longer than the check bits. Now, let's understand the calculation of cyclic redundancy check codes through an example. Given the information code 110011, we need to determine the redundancy code and the code word to be sent. According to the problem, we calculate the redundancy code to be 4 bits long. Using binary division, we find the redundancy code to be 1001 and the final code word to be sent is 1101111001. Now, let's summarize the content of this lesson. In this lesson, we learned about the causes of errors in data transmission are many and can be divided into internal and external factors. The parity check method includes odd parity and even parity. The cyclic redundancy check is also known as a polynomial code and has 4 characteristics of error detection capabilities. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. That concludes this mini lecture. Thank you, everyone.